Okay, in the last video, on part 2, I just got started talking about the identity equation. And so here's an example of an identity equation, and you might not see it right away, but here is an example. And when I start to solve it, I combine like terms on this side, and I got 3 here. And I noticed that I have x plus 3 equals x plus 3 is identical on both sides of the equation. And some students might see that right away. Some might not. If you don't see that right away, and I don't see it either all the time, what I would do is I would just keep solving this. I would pretend like it's a normal equation, a conditional equation on an exam, and I start to solve it. I would actually try to get rid of this x on this side by subtracting x, and do it on this side also. But what I notice is that I do that, then these x's go away and these x's go away, and I get something like 3 equals 3. Okay. That's a true statement. And that's always true, isn't it? Isn't 3 always equal to 3? But you'll notice that the variable dropped out of this equation. X is not there anymore. And so if you have a true statement like this, 3 equals 3, that means all real numbers is the solution to this equation. To indicate that, you can do the set of all x such that x is a real number. And we'll talk about that notation later on in this chapter. But I think in your homework it'll just say all real numbers or x is a real number. What that really means is if you go back to this equation right here, give me any number that you want to give me, any real number. Let's say I want 8. When I put 8 into here, so let's check 8. 8 plus 3, does that equal 8 plus 2 plus 1? So I put 8 here and 8 here. Well, I get 11 equals 11. I just picked a random number 8. What if your favorite number were 5? Let's check 5 in there. 5 plus 3, does that equal 5 plus 2 plus 1? I get 8 equals 8. So I could do this all day long. I could take every one of you guys in this class and I could ask for your favorite number, put it into here, and you'll always get a true statement. So that's what it means by all real numbers. If I put the S there, all real numbers. Okay? And the last type of equation that we have is going to be something called an inconsistent equation. An example of that would be something like x equals x plus 7. Some people will see this right away and say, well, x can never equal x plus 7 because this side I have the value of x, this side the value of x, but then I added 7 to it. So this side would never equal this side. But again, some students might not see that right away and they'll just try to solve it, which is fine. And if I try to get rid of x inside, I subtract x. Well, this side I get 0 because x minus x is 0 equals, and this side would equal 7 because this right here will equal to 0 right here. And I guess statement 0 equals 7, notice how the variable drops out again, but this time I have a statement that is never true. Does 0 ever equal 7? No. So that means if I take any number and plug it into here, for x, I plug the same number in here, I'll never get a true statement. So let's say I say 1. Does 1 equal 1 plus 7? No. What if I try 2? Does 2 equal 2 plus 7? No. So no matter what I plug into here for x and here for x, I'll never get both sides to equal one another. Okay, I hope you see that whether you see it right away or you start plugging in values. Okay? So that's never true, so this would be no solution. No solution, all real numbers, or we have a solution. Okay. So let's go ahead and see an example, and we're going to categorize what type of equations this is. So here I have 4x minus 7 equals 4 times x minus 1 plus 3. This one's really hard to see right away. I don't know. This looks like a normal equation that we've solved in the beginning of this section. And I'm going to treat it like it. So on this side of the equation, I'm going to go ahead and use the distributive property. We get 4x minus 4 plus 3. And then I have 4x minus 7. On this side I have 4x And when I go ahead and combine like terms, I get minus 1 here, so 4x minus 1. And some people might see right away this is an inconsistent equation, but if you don't see it, let's go and keep solving this. So minus 4x minus 4x. So this would drop away, and that would drop away, so I have negative 7 equals negative 1. And that's never true, right? That means I have no solution. This is an inconsistent equation. This means that there's nothing I can plug in for x in that equation, and both sides would ever equal the same thing. Okay? For example 8, I have 7x plus 9 equals 9 times x plus 1 minus 2x. Okay, again, I don't see anything right away, so I look at this, I go with the normal equation, treat it like a normal equation, try to solve for x. So on this side, I'm going to use the stirred property. I get 9x plus 9, drop down to minus 2x. Combine like terms, I get 7x plus 9 equals 7x plus 9. And I don't know, I say it out loud, I can hear myself say 7x plus 9 equals 7x plus 9. If you see right away that that's an identity equation, great. If you don't, then you keep solving it. Subtract 7x to get rid of it on this side. Subtract 7x to get rid of this side. Then I'm getting 9 equals 9. And that's when I can see it's an identity equation. What that means is I have all real numbers. So any number for x would work for this equation. Okay. That's the end of section 1.2, the solving equations, rational equations. So you're ready to go ahead and get started on your homework, and if you're in my class, we'll talk about this in class more. Go ahead and stop the video, and if you have any questions, please feel free to email me.